All right, stand by for some very, very bad art here, but I'm going to try and draw. I mean, instead of having a fancy movie or something like that, I'm going to draw what we mean by how athletes like Dr. J back in the day, or Michael, or even the stars today, how they can looks like they can elongate. It looks like they hang in the air, and I think one of the main reasons people think they have a long hang time is because, as Dr. J said in his commercial, he gets in his Dr. Pepper commercial, he talks about, my whole life has been in slow motion, and that's why people think that their hang times are longer than a second. But nobody, uh, even when we do the Wilt Chamberlain uh, calculation, nobody's hang time is more than a second. But too much yakking. But here we go. So when a projectile is launched, and we're going to look at projectile motion in chapter 6, when a projectile is launched, like when an athlete pushes off, it looks like this. Okay, here's the center of mass. Here's the path of his center of mass the entire time. All right, he's going, he or she is going through here. So the center of mass follows a perfect arc, especially with human beings, because we're so massive here on Earth, and we don't, air resistance is pretty much negligible. Now, a baseball that's spinning, a golf ball that's dimpled, they do not follow this kind of trajectory. In fact, a baseball, I'm kind of getting off track here, follows a trajectory that might look like this. Golf ball does the same thing. Golf ball does the same thing because of air resistance and drag, which we start to kind of talk about in, well, it doesn't curl back, but it'll go like that. Um, Start to curl, but a basketball player, doing a slam dunk, human jumping, that's their center of mass. All right. However, while they're going through this center of mass, while they're doing this jump, and let's draw their center of mass thing one more time. While they're doing this jump, and they're going to take off and land at the same speed that they went, and the if it takes them 0.45 seconds to get here, it's going to take them 0.45 seconds to get here, and the total time is 0.9 seconds. Okay, but like when they're here, what happens is, I'll just draw a stick figure of Michael here. And there's the center of mass right at his hips about. Okay, so there's Michael. If this is the scale, he's jumping about 9 feet in the air here instead of his 44 or 46 inches and 45 inches that he normally did. Okay, but anyway, so when he gets up in here, this part, his head, his spine gets longer. He can elongate his spine. Now, this is for dramatic effect only, all right? And so it looks like his head is going in like this. So his head's trajectory looks like this. They go up, and then they kind of ride it a little bit. Whoops, let me show you. Then they kind of ride it a little bit, and then it comes down like that. So there's this period right here before they come down where the head is going in, appears to be in a straight line. It kind of is. It's just not following the perfect arc, and so it looks like they're hanging. Okay? All right. Good.